Today's lesson is about density. So our question for today's lesson is, what is density and how is it calculated? Our keywords for this lesson are mass, volume, meniscus, float and sink. First of all, we have a knowledge check to complete, so make sure that you give yourself enough time to answer all 8 questions before the answers appear. So here are the answers. For number 1, draw the circuit symbol for a connection wire or connecting wire. So that is just a straight line. The circuit symbol for a lamp is a circle with a cross in the middle. You should then also show the wires each side of the lamp. The symbol for an ammeter is again a circle, but instead in the middle there is a capital A for ammeter. The circuit symbol for an open switch is a connecting wire with a gap in the middle, and either side of this gap there should be small circles, and there should then be a line showing the switch. So the switch should be not connected to both circles, but only one of them, showing that it is an open switch. For number 5, the circuit symbol for a cell is again very similar, so it's a gap between a connecting wire, and you have a long, thin line and a thicker, shorter line on the end of each part of the gap. The circuit symbol for a battery then is very similar to the cell. It's almost like a copy, except in between each copy there's a dotted line instead of just a bold, thick line. The line is dotted. And then for number 7, the circuit symbol for a voltmeter, similar to an ammeter, it is a circle with a capital V in the middle for voltmeter, and again it's in a circle, and you should show the wires either side of the circle. Does the current change in a series circuit? No, it stays the same throughout the whole circuit, so at any point within the circuit the current is the same amount. So today we are going to be looking at density, and our first question is, what is density? And most of the time we can see the effect of density through floating and sinking objects. So an iron nail will sink, but a fallen tree will float in a river. The tree and a ship both float despite their large mass because of their volume. Okay, because they both have a large volume, this then makes up for that large mass in terms of being able to float, whereas an iron nail has a very small volume. Objects float or sink then due to the relationship between mass and volume. And this is then what we call density. So it's the relationship between an object's mass and volume. Because the iron is denser than water, it sinks. Whereas because wood is less dense than water, it floats. So in order to measure density, because it is to do with the relationship between these two quantities, between mass and volume, we need to know the mass and the volume of an object in order to measure its density. In order to get a better idea then about density, watch the video below. You can either copy the link or you can just search the title, and it's the video by Smart Learning for All. There are also lots of really cool density experiments on YouTube that you can have a look at as well. Below I've included an example. This one below is to do with floating bowling balls based on bowling balls with different densities. Okay, but there are lots of different examples. The picture on the right There are lots of different videos showing different layers of materials, of liquids, because of different densities. So there's lots of different experiments that you can do to do with density. Make sure that you pause this video when you are watching the videos so that you don't miss any of the content for the lesson. The density of a substance is defined as the mass of 1 centimeters cubed of that substance. So remember that density is a relationship between mass and volume. The density is the mass of a specific volume. So 1 centimeters cubed is a volume. So the density is the mass of a certain volume of an object. Therefore, we can find the density of any object as long as you know its mass and volume. And then below we have then the equations that we use to work out density, both the word equation and the symbol equation. In terms of the units for density, there are 2 different units that we can use. So if the mass that we use in the equation is measured in grams and the volume is measured in cubic centimeters, so centimeters cubed, the density then would be grams per centimeters cubed. Whereas if the mass was measured in kilograms, the volume is measured in cubic meters, so meters cubed, then the density would be measured in kilograms per meters cubed. So the units of density that you are working out depends on the units that you use for mass and volume. So there's 2 different units that you can use for density, and you need to be able to remember both of those for when you are calculating density. So normally we would be able to do this experiment in the classroom. I have then a YouTube video in order for you to watch and get an idea of how to measure the density of a solid, specifically an object with not a standard shape. Okay, something that has an odd shape is much harder to measure the density of that object. So make sure that you either copy the link or you search up the title of the video. Make sure that you pause this video so that you don't miss any of the content. Now that we've had a look at density, I want you to try and order these materials from least to most dense. Obviously you don't have the amounts, the measurements of density for each material, so just have a think about what density you think these objects might have, and then order them from least to most dense. So hopefully you were able to at least have a go at trying to order these materials from least to most dense. So I'm going to order these then from the least dense being on the left and the most dense being on the right. So our least dense material from all of these is actually air. So air is least dense, whereas gold is the most dense. Ice is then next to air, so it is a bit more dense than air, but it is still then the second least dense of these materials. Water actually stays where it is, so water is in the third least dense, so it is a little bit denser than ice. So most people think that ice is more dense than water, but actually water is more dense than ice. Copper then is the second most dense of these materials. Glass then comes next. And perspex, which is acrylic, is then in the middle. So from least to most dense, we have air, we have ice, we have water, we have perspex, which is acrylic, glass, copper, and then gold is the most dense. Okay, so make sure that you mark your answers if you did give this a try. Okay, no worries if you got any mistakes. You know, you weren't aware of the measure of densities of these materials. It was just to see if you could guess, knowing what we know about density, which are the most dense and which ones are the least dense. Having a look at the density of these materials, having a look at the numbers then, we can compare the densities of these materials. So air has a very, very low density at 0.0013 grams per centimetres cubed. Remember that the other measurement for density, the other unit, is kilograms per metre cubed. But for this, we are using grams per centimetres cubed. Ice is then 0.9168, so just below 1 gram per centimetres cubed. Water itself is pretty much dead on 1 gram per centimetres cubed. Acrylic, so perspex, that is just above 1, so 1.185 grams per centimetres cubed. Glass is then over twice this amount, over double this amount. It's 2.7 grams per centimetres cubed, so nearly 3 grams per centimetres cubed. Copper is nearly 9 grams per centimetre cubed, so that's a lot denser than glass. And then even denser than that, and much denser, is gold. Gold is nearly 20 grams per centimetres cubed. It is 19 grams per centimetres cubed in terms of its density. So comparing gold to air, air is 0.0013 grams per centimetres cubed, whereas gold is 19 grams per centimetres cubed. There is a big difference between the density of air and the density of gold. So these numbers just put into perspective the vast range of densities that materials can have, and obviously puts them into order in terms of least and most dense materials. Try your best to remember these as some examples of the density of materials. So make sure that you have a note of these densities of materials. So perhaps under your list of least to most dense, add these numbers for density of the materials onto your booklet. So something that we just spoke about in terms of ordering those materials from least dense to most dense was the fact that ice is less dense than water, and it's something that most people are not aware of. They mostly think that ice is more dense than water because it is a solid compared to then a liquid. Okay, but ice has a different structure than liquid water. That structure is that the molecules are in a lattice, rather than the molecules being randomly arranged within the liquid. So on the bottom right hand corner there is a picture showing the difference between the structure of the molecules in ice compared to liquid. So on the left it's showing the structure of ice, that is what the lattice looks like, and on the right shows what the molecules in liquid water look like. How they are arranged randomly. This lattice arrangement that ice has allows the water molecules to be more spread out in ice than in liquid water. This then gives ice a lower density than water. So it's this arrangement and the fact that the molecules are able to be more spread out that means ice is less dense than water, and that is then why ice floats on water. So as you can see on the top right picture, there is a huge iceberg and it is floating in the water. Most of the iceberg is underneath the water, but there is still some iceberg then on top of the water. It is floating up the surface of the water. Another question that we might ask is, why do bubbles of gas rise through a fizzy drink? This can be mostly explained by the density of the gas, so carbon dioxide, which makes up the bubbles, and then the density of the drink itself. So you can see the numbers on the top. So carbon dioxide has a density of 0.001836 grams per centimeters cubed, whereas cola, the drink itself, has 0.61 grams per centimeters cubed. The bubbles in fizzy drinks are formed of carbon dioxide gas, so they have a very low density, whereas the drink itself has a density higher than that. For example, cola has 0.61 grams per centimeters cubed as a density, compared to 0.001836 grams per centimeters cubed. So because carbon dioxide has a lower density than the drink, the bubbles rise through the fizzy drink. Before we finish this lesson, we have a knowledge check to complete. So make sure that you give yourself enough time to answer all 11 questions before the answers appear. Make sure that you pause the video so you have enough time. So here are the answers. The reason an iron nail sinks when it's put into water is because the iron has a higher density than water. A piece of wood floats when it is put into water because the wood has a lower density than water. We then have two units of density. One of those is grams per centimeters cubed. The other unit of density is kilograms per meters cubed. So it doesn't matter which way you put these around, but you should know both units for density. The equation for density in symbols is D equals M divided by V. And in terms of words then, that is density equals mass divided by volume. When you order the materials water, perspex and copper in terms of highest to lowest density, we have copper being the highest density. Next would be perspex, that's acrylic. And the lowest density then is water. The density of a substance is the mass of 1 centimeters cubed of a substance. So here we have three materials, gold, water and air, and it's then given you three densities, and you need to match up the materials to the densities. So gold has the highest density, it's 19 grams per centimeters cubed. Water has a density of just 1 gram per centimeters cubed, and air then has 0.0013 grams per centimeters cubed. For number 10, you are calculating the density of a brass nut when it is giving you the mass, so 34 grams, and a volume then of 4 centimeters cubed. So bearing in mind that our mass is in grams and our volume is in centimeters cubed, our density, the unit for it should be grams per centimeters cubed, and I've worked it out to be 8.5 because you divide 34 grams by 4 centimeters cubed. And the reason why bubbles of fizzy drinks rise is because the carbon dioxide which makes up the gas in the bubbles has a lower density than the drink itself. Make sure that you give yourself a mark out of 11. Make sure that you make any corrections in a different coloured pen. Last of all, then, we need to highlight our key words. So volume is the amount of three-dimensional space occupied by an object. Okay, and it can be measured in centimeters cubed or meters cubed. The mass is an amount of matter in an object, remembering that matter is anything that takes up space. And a meniscus is the curve in the upper surface of a liquid close to the surface of the container. So when we are measuring a volume of liquid, we measure at the bottom of the meniscus. That is the end of our lesson for today. Thank you.